All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies course, I've been doing a series of video presentations based on the Mozilla Developer Network Learn Web Development series. We're in the JavaScript section. We're talking drawing graphics, and we've gotten up to loops and animations. So far, as it says, we've discussed very basic uses of the 2D canvas, but really no animation. All right. And as it says, after all, Canvas does provide scriptable images. If you aren't going to change anything, you might as well use static images and save yourself work. So playing with loops is rather fun. You can run Canvas inside of a for or any other type of loop. Let's build a simple example. So let's go back to the file that we've been using. Copy it to the clipboard. Replace the one that's in there, save it, and go back to our document. All right. Add the following line below the bottom of your JavaScript, which has the translate message, which, as it says, moves the origin point of the canvas. Oh, I don't know what happened there, but not what I wanted to have happen. Copy. There we go. And again, if you'd like, you can move that out so it looks a little bit nicer as well. Okay. As I've been doing, I'm just going to move this over. It's much easier for me then. I don't have to worry so much about lining stuff up, etc. So this causes the coordinate 0, 0 to move to the center of the canvas rather than being in the upper left-hand corner. Now add this to the bottom. Here we are implementing the same degrees to radians function we saw in the triangle example above, a random function that returns a random number to give between lower and upper bounds, length and offset to be set in an empty for loop. The idea here is that we're going to draw something on the canvas inside the for loop and iterate it on each time through so we can create something interesting. So put this inside of the for loop. All right, there it is. And what I am going to do, let's see, just leave it like that. That's fine. So it says then with each iteration, we will set the fill style to be a shade of slightly transparent purple, which changes each time based on the value of length. The length gets smaller each time the loop runs, so the effect here is the color gets brighter with each triangle that's going to be drawn. Then we begin the path, move the pen to our coordinate, which defines on how far we want to move it each time we draw a new triangle. We draw a line parallel to the x-axis, calculate the triangle's height, draw the rest of the triangle, and then fill in the triangle and update the variable. Looks like it should look like this when we get done. Let's see. And there it is. All right. The loop example above was fun, but really you need a constant loop that keeps going and going for any serious Canvas applications such as games or real-time visualization. If you think of the canvas as being like a movie, what you want to display, you want the display to update on each frame with an ideal refresh rate of 60 frames per second. We talked about that much earlier. There are a few JavaScript functions that will allow you to run functions repeatedly several times a section, but the best one for ours is one we've already looked at. Request animation frame, which takes one parameter, the name of the function, to run for each frame. Note it's good practice to call cancel from your main code when you're done using the animation to ensure that no updates are still waiting to run. All right. The source code for the loop that does everything looks like this. So let's grab this. Let's come back into here. Let's remove what we had put in before, which I believe was all of this. We'll know real fast whether I did this right or wrong. All right. Just grab a bit of this and do what I have been doing here. Looks correct to me. Let's see if this does it. And it did nothing. We run the loop once at the bottom of the code to start the cycle, drawing the first animation frame in the loop. Let's see. Well, it was supposed to look like this. We'd already talked about this once. So ours is doing nothing, as you can plainly see. And I'm not going to go back. I guess I could throw all this stuff in there, but I'm not going to do that. All right. So let's take a look at it. Not that one, this one, right? In the See It Live. And I guess it's not allowing us to go take a look at the code. So we run the loop function once at the bottom of the code to start the cycle, drawing the first animation frame. The loop then takes charge of the request animation frame loop to run the next over and over and over again. Note that on each frame we are completely clearing the canvas and redrawing everything. For every ball present, we draw it, update its position, check to see if it's colliding with any other ball. Once it's been drawn to the canvas, there's no way to manipulate that graphic individually like you can with a DOM. You can't move each ball around on the canvas because once it's drawn, it becomes part of the canvas. And it's not accessible to any individual or to an individual. It is not an accessible element or object. All right. So optimizing graphics, animation of graphics is an entire specialty of programming with a lot of different tricks. In general, the process involves the 5 steps that are shown here. First, you clear the canvas contents using fill rect or clear rect. Next, you save the state, which is needed as it says if you want to save settings that you've updated before continuing. Next, you draw the graphics you're going to animate. Then you restore the settings you saved in step 2, and you call request animation frame to schedule the next animation. So let's create our own simple one. I've got that again, and we're supposed to make a copy of this. All right, that'll make that. And we want a fresh copy of the one canvas template, so let's grab that. As I have been doing, let's fix this, so to speak. All right. All right, done. At the bottom of the JavaScript, put in that line which we had before. Which again should center this on the screen. Now let's create a new image element, set its source to the image we want to load, and add an onload event handler to it. Now we'll add some variables to keep track of the position the sprite is to be drawn on the screen and the sprite number we want to display. 0, 1, 2, 3, 4, and 5, I would believe. Okay. Now, this is me speaking here, but I find this interesting because it says, let's explain the sprite sheet image, which we have borrowed from a different article that they reference there. It contains 6 sprites that make up the entire walking sequence. Each one is 102 pixels wide and 148 pixels high. To display each sprite cleanly, we have to use draw image to chop out a single one. All right. Now, it's not the same thing, but one of the things that I did in the C# class is I went out to images.google.com. And, okay, you have to spell it right. But I went out here and I looked up Magic 8-Ball. All right, and I found someplace in here, and I know, there it is, I found this one. So what I did was I went in and cut out each one of these and I made it into 15 different files. All right, so I basically just grabbed the stuff out of there and did that myself. And it's kind of the same type of an idea here. All right, now let's insert an empty draw function. Next, we'll draw the image using draw image. All right, there's the image we want to draw. These two parameters specify the top left corner to slice out. These are the size of the slice to slice out. This is the top left corner of the box you want to draw into, and this is the size of the image on the canvas. All right, now we'll alter the sprite after each draw. So add the following. Basically what it's saying is, if you've reached the last sprite, go back to 0, otherwise go up 1 sprite. Okay, so go to the next sprite, in other words. All right. Next, we need to work out how to change the X position on each frame. So add the following code. It says we are using another if-else statement to see if the value of pos X has become greater than the width divided by 2. You don't want the character to walk off the right-hand side of the screen. So if he gets to the end, it sounds like we want to move them over to the left-hand side of the screen. So it's going to look like this, if we do it right. And finally, we need to make the animation loop by calling the request animation frame. So ideally, when we do this, it's going to look like this when we get all done. Let's check it out. Well, he's there, but he isn't moving. Out of curiosity, well, that isn't doing a flaming thing. So obviously I skipped something. Don't want that. I don't think that would be enough to make it not work though, but I don't know. Nope. Since the finished code is available there, yeah, that's fine. Whoa. Try to see how I got that guy to go faster. That was kind of neat. All right. So let's look. I'd like to get this to work to prove to myself and to you that I can get something in here to work. So sprite equals 0, x equals 0, good. Our function draw. Oh, I didn't put in this line right here. Let's see if, I mean, it probably is fairly important. Looks like it's a positioning type of thing. So let's see what that does. Did, if anything. Come on, you. Brother. The rest of the code in this section goes inside of draw. First, add the following line. Okay, we put that in. Well, if this all goes in draw, then this has got to go at the bottom. So then put in that, as you can see. Next, we alter. Okay, let's do this. Now it said the rest of it, so I'm assuming even the draw goes in there. All right, let's look and see what that did. There he goes. Let's see when he gets to the end, if he comes back, he gets to the end of the right side, does he come back on the left side? There he is. Okay, that's kind of neat. Now that's a very simple animation. It may not seem like it to me and you if we've never done one before, but really the amount of code that it took, etc., was not terrible. All right. I'm at 19 minutes. That's a good place to stop, I guess. And we'll pick it up on this sample drawing. Well, it says we'd like to show you a sample drawing application. All right. Yeah, let's take a look at that in the next video.